everyone, welcome back to AP Environmental Science. In today's video, we're going to be covering two topics. We're going to be covering 5.5 sustainable agriculture and 5.6 irrigation methods. Okay, so let's get into 5.5 sustainable agriculture. Okay, so soil conservation is going to be any kind of agricultural techniques that minimize erosion. Remember, erosion is going to be the loss of topsoil over time, and we don't want that because it is going to harm the soil. It prevents plants from growing, and we want to have a nice, stable root system. That way, we do not have erosion occurring. Now, unfortunately, a lot of these agricultural practices that we discussed in 5.4 is going to, unfortunately, increase rates of erosion. So soil conservation is trying to combat that. So the U.S. is currently losing topsoil to erosion 10 times faster than soil forms. So when we are going to perform soil conservation, we are going to prevent the loss of nutrients in topsoil. We're going to maintain our soil moisture. We're going to have our decomposers in the topsoil and organic matter that traps soil moisture. I'm sorry to be coughing so much. I'm still getting over COVID. Okay, so here are some ways that we can perform sustainable agriculture. One of them is contour plowing, which is plowing parallel to the natural slopes of the land instead of down slopes, because that's going to prevent water runoff and soil erosion. So it forms these mini terraces that catch water running off, conserving soil and water. And it looks something like this. Okay. Terracing is cutting flat platforms of soil into a steep slope. The flatness of terraces catches water and prevents it from becoming runoff and eroding the soil. Okay. And now we have perennial crops. These are crops that live year-round and are harvested numerous times a year. And they form these really nice, long, established root systems, which anchor the soil and prevent soil erosion. So we want to plant these perennial crops because they grow all the time. There's no need to uproot them and till the land if we have these crops and they grow year round and they can be harvested multiple times. Windbreaks are using trees or other plants to block the force of wind from eroding topsoil. Remember, rain, wind, water, weather, those are all things that increase rates of erosion besides agricultural practices. So natural ways that soil erosion occurs is rain and wind. And there are a plethora of ways that humans cause soil erosion. So windbreaking is a way that we can reduce natural soil erosion from occurring, and we're going to be using trees or other things to block the force of the wind. And this is nice because it could be used as a source of income. Firewood, fruit, it provides income, can provide habitat for pollinators and other species, and it looks something like this, which is great. And let me move my thingy here a little bit. Boop, 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 boop. So when you have the winds, the prevailing winds, they are going to, go through the trees, but the trees are going to primarily stop the force of the wind, and most of the winds are actually just end up going over the trees in general, not reaching the ground. That way you're not losing any topsoil to wind, resulting in erosion. The no-till method, we just leave the leftover crop remains in soil rather than tilling underneath it. This is going to add organic matter to the soil, which can be nutrients, soil cover, and moisture, and it prevents erosion from the loosened soil. And strip cropping. It's another name for intercropping, but it's, the same thing, alternating rows of dense crops, hay, wheat, with rows of less dense crops such as corn, soy, cotton, to prevent runoff from eroding the soil. Okay. Improving soil fertility. Crop rotation. Replanting the same crops continuously depletes the soil of the same nutrients, because all different plants, why won't this move? All plants require different levels of nutrients. So if corn requires more levels of potassium than, let's say, a bean species, if you're only planting corn, it's going to be uptaking so much nitrogen or phosphorus, whatever it needs, whereas other species of plants might not need that much nutrients. So when you do crop rotation, you're able to allow the soil to recover from nitrogen and phosphorus demanding crops. So here we go. Peas, beans, they already have nitrogen fixing bacteria in their root nodules that can return nitrogen to the soil. So we want to make sure that in our fields, we can plant corn, but every single season we should not be planting corn. We want to rotate them out with other things like beans and peas, mainly because they do have this wonderful ability to fix nitrogen and can return nitrogen to the soil. Green manure, this is leftover plant matter from a cover crop, which is a crop planted in the off season between harvest and replanting of the main crop. Cover crop roots stabilize soil, limiting topsoil erosion. The remains of cover crops left on field break down to release nutrients in soil, which is good. Returning nutrients to soil, we have a better crop yield. Limestone releases calcium carbonate, which neutralizes acidic soil. Acidic soils have a high concentration of hydrogen ions, which displaces positive charged nutrients from soil, causing them to leach out into the ground. So acidic soil also makes toxic metals more soluble in soil. So we want that. And calcium is also needed in plant nutrients. Rotational grazing. This is the regular rotation of livestock to different pastures to prevent overgrazing. This is something that has been a common example to combat the tragedy of the commons. Overgrazing can kill plants, compact soil, and lead to erosion of topsoil. Rotational grazing can actually promote pasture growth at a faster rate than normal rate. Clips grass back to length where growth is the fastest and encourages deeper root growth. And that is what we want. So rotational grazing is we are just simply switching out the areas where livestock graze over time rather than just leaving them in the same plot, because eventually they're going to eat all of the grass. It'll be really hard and take a really long time for it to grow back to a sustainable length. And we can see here the differences in the roots between grasses being cut to 2 inches every week, 2 inches every 2 weeks, and then 2 inches every 4 weeks. The longer we spend in between cuttings, we have a longer root system in order to prevent soil erosion. Okay, irrigation. Okay, so this is all ways that we get water to our fields. Okay, so furrow irrigation is a trench dug along crops and filled with water. It's easy and inexpensive. Water seeps into soil slowly. It is 66% efficient and 33% is lost to runoff and evaporation. Drip irrigation is the most efficient but the most costly. It's 95% efficient. There are holes in the hose that allow water to slowly drip out. It avoids waterlogging and conserves water. Flood irrigation is when you flood the entire field. It's easier but more disruptive to plants, can waterlog the soil and drown plants. It's 80% efficient and 20% is lost to runoff and evaporation. Spray irrigation is ground or surface water is pumped into spray nodules. It's more efficient because you have less water loss than flood or furrow, but it's more expensive because it requires energy and pumps and the movement of sprinklers, which all cost, manpower, machinery, time, assembly, that kind of stuff. Okay, so waterlogging can saturate the soil, filling all soil pore space with water. It doesn't allow air into the pores, so roots can't take in the oxygen they need. It can stunt growth or kill crops. This is why, they say that you can't really ever give your plant that much water or too much water because it just takes in what it needs. That is true for most plants. However, in the case of crops, if you are completely waterlogging the soil, you can see here that there is no space for air bubbles, so there is no space for oxygen to get in, and plants actually do need oxygen because they do perform cellular respiration as well. So the solution to this is the drip irrigation, or we provide some kind of soil aeration, which is poking holes or cores into soil to allow air in and water to drain through the soil, kind of like this. Okay. Soil salinization. This is what we are doing our entire lab on the week that we come back from Martin Luther King weekend, and you will have a lab report to write on this. So this is a good one. All right, so what is soil salinization? Soil salinization is the process of salt building up in soil over time. Groundwater used for irrigation naturally has small amounts of salt, but when the water evaporates and salt is left behind in soil, it can eventually reach toxic levels, and it dehydrates plant roots and prevents growth. So solutions to this are drip irrigation, soil aeration, flushing with fresh water, and switching to a fresh water source. Okay, this is a breakdown of the global human water use. Our next unit is actually all about water and like the ocean. So this is kind of a snippet into that. So 70% of global human water use is being used specifically for agricultural purposes. Okay, agricultural purposes, meaning crops and livestock. Okay, industrial is going to be things like factories, any sort of energy power plant. You do need water to cool a lot of these power plants, specifically nuclear power plants and coal. So 19% is being used for the industry, and 11% is used for municipalities, which is going to be human, like everyday residential use. So industrial, power plants, metal, plastic manufacturing, municipal, household, which is your toilet, shower, drinking water, and agricultural, water for livestock, irrigation, water for crops. I'm not going to go into much of this now because we have a whole unit on water and aquifers and groundwater. So you can fill in your notes now, but I'm going to go into this more deeply in the next unit. Okay. And again, as a reminder, I've reiterated this so many times, our largest source of fresh drinking water that we use for everyday use comes from the ground. Okay. It comes from groundwater. Yeah, I'm not going to go over those things. That's actually nice and quick because we're going to go over it in our next unit. All right, so have a wonderful day. I will see you guys when I see you. If you need anything, let me know. Keep up the amazing